and they're not a high school, then they're going to beat you. In the SEC, it's not a luxurious, play high school league. It's a pretty tough league, conference. So, oh well. And no comment. Okay, well, we'll just go ahead and start because nobody's going to talk this morning. So I got 3 or 4. Let's go over it, and then we're going to start 6.2 because we got to get done with at least 6 and 7. So let's see, that's 6.31, 25, 28. Okay, so 6.1, 25/8. 6.1, 25/8. Okay, we've already done this, but I'll do it again. Suppose a life insurance company sells a $280,000 life insurance policy to a 20-year-old female for $270 payment, yearly payment. The probability that the female survives the year is blah, 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 blah. Compute and interpret the expected value. Remember, expected value means average of this policy to the insurance company. Now remember, 2 things. 1, you're looking at this from the perspective of the insurance company. And you also got to remember that when you're dealing with just numbers, it's called average. When you're dealing with money, it's called expected value. So with those 2 things being said, let's go ahead and I'm getting everything pulled up for you. Okay, first of all, we got to draw a table. And y'all let me know, did I cover this with y'all last week? I thought I did. Yeah, Hubert, I remember you did. Nobody's going to say anything. So you got 2 choices, live or die. This is the event, and this is the probability of the event. Well, you're given the probability of living is 0.999538. The probability of dying is the complement of that, which is going to be 1 minus 0.999538. I don't know why. Does that look blurry to y'all?
A little bit.
I don't know why it's not. It's supposed to automatically. Is that better? Yeah, it's better, Hubert. Thank you, class. So the complement is 3 zeros, 462, 3 zeros, 462. Okay, so if she lives, the insurance company gets $270. If she dies, what happens? Now, I'm not going to answer that for you. I need somebody in the class to tell me what happens if she dies.
They pay out $280,000 minus $270.
Thank you. And notice Miss Stewart said they pay out. Okay, that's the key word here. If she dies, the insurance company has to pay out $280,000. Okay, but from the insurance company's eyes and their books, as far as the file on Miss Female, she's already paid $270 because that's her yearly payment, which in insurance is called a premium. I don't understand why in cars and houses it's called a payment and in insurance is called a premium. I don't understand that. I never have understood that. But to make a long story short, the company has to pay out, it'd be $279,000. Let's go ahead and subtract it. $270 minus, since they have to pay out $280,000, $279,730. Now remember, you're looking at this from the insurance company perspective. I don't think that's right. Perspective. Okay. All right. So that means that the 270 that came in, that's positive, and the 279,000, that's going out. So that's why it's negative. Let's just put coming in, paying out. So of course, the mean of a probability distribution is equal to the summation of x times p of x. So you're going to find the mean of this setup. So I'm going to take this times this and add it to this times this. Now, I usually do this on the Excel spreadsheet, but since I'm doing it on the calculator, I'll do it on a calculator. Parentheses, 270 times 0.999538, close parentheses, plus, open parentheses, negative 279,730 times 0.000462, close parentheses, and enter. So the company, the insurance company, basically is going to profit, because it's a positive, $140.64 when she makes each year. $140.64. And that's that right there. And that's pretty self-explanatory because it's the only one that says 140.64. Now, I'm not going to say this is a test question, but I can tell you right now, it's a standardized test question. They usually ask this type of question on a standardized test. Next question. 6.128. An investment counselor calls with a hot stock tip. He believes if the company remains strong, the investment will result in a profit of $40,000. If the economy grows at a moderate pace, the investment will result in a profit of $10,000. However, if the economy is the investment will result in a loss of $40,000. You contact an economist who believes there is a 20% chance probability will remain strong, a 60% chance the trouble will grow, and a 20% economy will slip into recession. Same type problem, except you got three things now. Now, I've never seen this problem before, so I'm going at it from, probability, event, and probability. So you got three this time. You got the economy is booming. The economy is just staying at status quo, and the economy tanking. X, probability of X. They give you the probabilities. They say that 20% probability that it will stay strong, 60% that it will continue to build, and 20% that it will tank. And if it tanks, you're going to lose $40,000. If it stays building, it's going to be $10,000. And if it's real good, it'll be $40,000. And I bet you they want to find the expected value. Yep. So again, summation of X times P of X. Mu is equal to. So expected value is going to be this times this, plus this times this, plus this times this. So take your handy dandy calculator. Parentheses, 40,000 times 0.2 plus parentheses 10,000 times 0.6 close parentheses plus open parentheses negative 40,000 times 0.2 close parentheses. 6,000. So that's a profit of $6,000. Or a expected profit. So that'd be 6,000. Fantastic. That's a good test question. Those are short and sweet. Next one. 6.131/10. I don't know if we've covered this one or not. Yeah, we covered that one. Didn't we cover? I need somebody to verify that we did this one. I'm pretty sure we did.
Yeah, we did.
Okay, thank you. Appreciate it, Miss Stewart. I'm going to have to buy you a donut just for interacting with me. 6.131. Huh?
Take it.
I hear you. All right, so I'm not going to delete those first two because they're from the other class. But I'm going to delete these two because they're the same one. And let's get into 6.2. So 6.2, we've tried to start several times, and we ran out of time each time. I had it. Where is my, there it is. And we got a little bit, and I told you that before we start, I told you that the big difference between 6.1 and 6.2 is 6.1, you're dealing with the mean and the standard deviation of a probability distribution. So the mean and the distribution of a probability distribution. So basically, if you're given a probability distribution, 0, 1, 2, 3, 0.2, 0.5, 0.15, and 0.15. I want to find the mean and the standard deviation of that probability distribution. Okay, so that's 6.1. 6.2, you're not going to be given a probability distribution. Okay, in 6.2, you're not going to be given a probability distribution. You're going to be just given N, P, and X. Okay, and you're going to be asked to find the mean and the standard deviation. Well, you're going to be asked to find the probability of an event, and that event is going to be X. Okay. Okay, so you're going to be asked to find the probability, and then you're going to be asked to find the mean, and then the standard deviation. And Q is the complement of P. Q equals 1 minus P. So I think I covered this with you a couple of times and we ran out of time, but that's the difference between 6.1 and 6.2. Okay, in 6.2, you're just going to be given 3 numbers. N is always your biggest number. P is always a percent or decimal or probability. And X is the event that is going to be tested for the probability. Okay, so that's the difference between the two. So it's very important you write this down and understand this, because this is what you're doing in 6.1 and 6.2. And 80% or 60% of your test is going to come from 7.1 and 7.2. So 40% is going to come from these two. So probably 2 or 3 questions from each section. And you still have to remember these 4 things. Those 4 things are still applicable on both of these. So let's see how far, I can't remember how far we got in the slides. I got to get to 6.2. I never got to it. There we go. And I think we covered that. We covered this much. And we covered player rolls a pair of dice. And here's the test right here. Right here. So if we didn't cover this, you might want to, and somebody can look in your notes. I can't remember if we covered this or not. But how to tell if something is a probability distribution or probability experiment, a binomial probability. The experiment is performed a fixed number of times. Well, a fixed number of times would be something like, hold on a second. A fixed number of times would be something like, trying to get this where you can see it. Flipping a coin 50 times. Okay, so N is equal to 50. Okay, the trials are independent, meaning that when you flip a coin, the only thing that decides what that coin does is gravity and basically how it hits the surface. Is there anything on that coin that dictates how it's going to flip? No. It's not balanced on one side more than the other side. There's no kind of mechanism to make it flip to hit tails. In other words, it's just like a rolling of the dice. There's nothing to keep it on one number unless you got some kind of magnet or weight in it or something. Okay. Here is the kicker right here, 3. For each trial, there is 2 outcomes. And how this usually is done is either it's yes or not yes. Okay, so if I asked you, if I go up here and I tell you that the probability of tails in this 50 times is equal to 0.6. Okay, then that's my P. I've got N and I've got P, and the flipping a coin doesn't matter. And for each trial, there are 2 outcomes. Well, either it is heads or it is what? Tails. There's 2 outcomes. That's why it's called binomial. So I'm going to put a red marker here and put binomial in quotation marks. Binomial means 2 answers. Now, what about rolling a die? Well, rolling a 6. Well, either you roll a 6 or you what?
Don't.
Don't roll a 6. Again, thank you, Miss Stewart, for your interaction. I'm so glad you're not weaned on a pickle. All right. And 4, the probability is fixed for each trial. So it pretty much is fixed whether you have success or failure. Now, I'm going to tell you what the last question would be on this question. Okay? The last question would be, what is the probability of tails if you flipped 10 more times? And that is X. Okay? So here is N, here is P, and here is X. This is an example of a problem that you would see for a binomial probability distribution. It should just say binomial probability because there is no distribution per se like there was here. Okay. They just give you a paragraph and it says, while flipping a coin 50 times, you come up with a probability of tails is equal to 0.6. What would the probability of tails be if the coin was flipped 10 more times? That's the way the question will be asked.
You said the probability of heads is P?
The probability of heads, I said the probability of tails.
Okay.
I said the probability of heads or tails is 1/2. What did I misspeak? Is that what you're telling me?
No, I didn't catch what you said. I heard you say the probability of tails flipped 10 more times is X.
No. What is the probability of tails if it's flipped 10 more times? That's what you're trying to find. And that's what NPX is. And you're going to type it in the calculator, and it's going to spit out a probability of those 10 more times. It'll make better sense when we actually get to a problem. And remember, Q is equal to 1 minus P. They don't put that in here. And they use 1 minus P. I mean, why use 1 minus P when you can use Q? A lot of books use Q. I don't know why this book refuses to use Q, but I don't know. N is always your biggest number. P is going to be a probability, usually by a ratio, a fraction, or a decimal, or a percentage. And Q is 1 minus P. And that's the complement of P. P is success, Q is failure. Let X be what you're asking for, which is going to be smaller than 50 or smaller than N. Okay, this is a binomial experiment because a player rolls a die, figured 10 times. The number X of sevens, either it's going to be a 7 or it's not going to be a 7. Okay, but it's not a binomial experiment because there's not a fixed number of trials. Okay. Oh, I'm sorry, I skipped one. Hold on. Shoot. There it is. Why isn't it? Okay, that is an example. Well, okay, it is. They didn't put anything here. This is a binomial experiment because you got a fixed number of times and the number of sevens is recorded. It's either 7 or not 7. That's a binomial experiment. The 11 largest airlines will basically read this whole thing. They don't even offer a fixed number of trials. They just tell you that the 11 largest airlines, an official randomly selects until she finds 10 that were not on time. Well, those 10, those are not on time. She didn't tell you how many she went through to find those 10. So you don't have a fixed number of trials. In a class of 30 students, 55% are female. The instructor randomly selects 4 students. The number of X of females is selected is recorded. The trials are not independent. In other words, if she picks 4 students, does she put them back another 4 students? Because if she does that, then that's defeating the purpose. So that's not a good example of a binomial experiment. Usually a binomial experiment is going to have to do with yes or not yes. In other words, tails or not tails, 6 on a die or not 6 on a die, something like that. Okay, here's a problem that you might see on a test. According to Air Travel Consumer Reports, the 11 largest airlines carry an on-time percentage of 79% in May 2000. Suppose that 4 flights are randomly selected. Now that's the difference between this one and the other one. She just went and picked 4 that were on that were not on time. You just can't pick something that you want, you have to pick 4 and find out. So suppose that 4 flights are randomly selected, blah, 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 the number of flights. So N, yeah, okay, construct a probability distribution. Now, this one, I'm going to show you an easier way of showing you this. Okay, let's forget about this right now. I'm going to go and I want to ask you, and this is how you construct the probability distribution, but we're not going to worry about that on the test. I'm just going to show you how to do it for your own, so you'll know it. Constructing a probability distribution. Okay, so let's use an example of 2 children. A couple wants to have 2 children, and you want to do a probability distribution based on 2 children. So the parents can figure out what their probability, and you work for a fertility clinic, and the probability of having a boy is equal to 0.52. Usually it's 0.5, but you have done calculations over the years and you've kept an up-to-date probability of 0.52 for the clinic. That basically means you got a 0.52 chance of having a boy. So with 2 children, let's do the probability distribution. Well, there's boy, boy. There's boy, girl. There's girl, boy. And then there's what? Girl, girl. Now we're going to do the probability distribution of all of those. So here we go. X is the event. That would be boy, 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 girl, girl, boy, and girl, girl. Now, if the probability of a boy is 0.52%, somebody tell me what the probability of not a boy is equal to. Which is the probability of a girl. What's that? Equal to what?
0.48.
Good job. So this one, probability of the event happening, is going to be 0.52 times 0.52. This is going to be 0.52 times 0.48. This is going to be 0.48 times 0.52. And this is going to be 0.48 times 0.48. And that's going to equal 0.52 squared. .2704. .52 times 0.48. 0.2496. And 0.48 squared. .2304. Now, the probability distribution will look like this, and you saw this in 6.1, which what I'm showing you, should have been shown in 6.1, but we're not going to go there. Okay, 2 boys are 0 boys would be 2 girls, which would be 0.2304. 1 boy would be 2 times 0.2406. That'd be 2 times 0.2406. No, 2496. 0.4992. These are together. And
your
2
calculator's
boys.
blocking where you're writing.
I'm sorry.
It's okay.
Thank you for saying something. And the last one would be 0.2304. I'm sorry, 0.2704. This is what you saw in 6.1. Okay, and this is how you do it. Now, I'm not going to test you on constructing one. I just want you to be aware of how to do it. But they're going to have to give you the probability, and then you figure Q. P is 0.52, therefore Q is equal to 0.48, and you actually have to multiply it by each one of these. And that's how I got the probability. Really, like I said, I think that should have been taught in the first part of 6.1. But the reason they didn't teach it in 6.1 is because it was a different type. It wasn't yes or no. It wasn't true or false. It wasn't boy or girl. It was how many, events, like 0 games to 1 game, 2 games. So it was a little bit different. This is a binomial distribution. Either 0 boys, 1 boy, or 2 boys. And the binomial probability is either a boy or a girl. That's the binary. And that's what they're showing you in this slide. They're taking those probabilities and they're multiplying by, like, 0 would be, there you go. 0 would be like 0 would be 2 girls, would be 0 boys. And that's what they're doing. See? They're doing the same thing I did, except I did it on a smaller scale. There's their probability distribution. Here is the formula. Write that formula down. You don't need it. You don't need to use it, but you need to have it. When finding NPX, the probability X, type it in that formula. NCX P to the X power multiplied by 1 minus P raised to the N minus X power. And X is positive. Now, there's the formula, and you need it for your notes, and say it's the formula for a binomial probability distribution. But I'm going to show you how to do it in your calculator. And we talked about these. We've already talked about that. I'm going to leave that as a minute for you to copy that down, but we've already talked about it. Okay. And if you need more time, just go to the video and hit pause. You got plenty of time to write it. Okay, here is an example of the way the question will be worded. According to the Experian Automotive, 35% of all car-owning households have 3 or more cars. 35% have 3 or more cars. In a random sample of 20 cars, 20 car-owning households, what is the probability that exactly, it means equals, have exactly 5 have 3 or more cars. 3 or more cars doesn't matter. It could be blue cars. It could be trucks. It could be 3 or more cars. That's not mathematically relevant. Okay. You've got n is equal to 20. I'm going to write this down in this problem. N is equal to 20. P is equal to 0.35. And X is equal to 5. Now let's pull out the handy dandy calculator. You need to write this down now. I'm fixing to show you how to do these. Second, bars. Turn it on first, dummy. Second, bars. And go down to see binomial PDF. Second, bars, and go down to binomial PDF and hit enter. Number of trials, 20. P, 0.35. And X value is 5. So what they're saying is, what is the probability of 5 households that have 3 or 4 cars? Now, if you have an older type calculator, it's just going to say parentheses, and then you would type in 20, comma, 0.35, comma, 5, and then close parentheses. And hit enter, and there is your probability. Probability of 5 households is equal to 0.1272. Most of the time, it's safe to do 4 decimal places because they usually ask you to round to the second or third, or sometimes they just leave it round to the fourth. That's why I don't have you do the formula, because it's easier just to do it in the calculator. And that's what the calculator is for, to do problems like this. Now let's look at the next problem. In a random sample, blah, 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 what is the probability that less than? All right, now the first thing I'm going to do is I'm going to draw a number line. What is the probability okay, n is equal to 20. P is equal to 0.35. And X is going to be less than 4. So I'm going to draw my number line. so I can actually see and I think it goes up to 20. Okay, so I want you to shade less than 4. What would less than 4 shaded be? Well, that'd be 3, 2, 1, and what? 0. So I've got to do NP0 plus NP1 plus NP2 plus MP3. So that's how I'm going to do it. So take my handy dandy calculator. I'll show you a trick I learned in the war. Oh, sorry. Hold on. Delete. Second, quit. Second, quit. There. All right. I'm going to hit second entry. And look at there. It already does it. It already pulls up the last one. And I'm going to do NP0. So the probability of 0 is 3 zeros and a 1/8. But I'm going to store it. What do you mean store it? Well, where do you get bread? At the stove. So I'm going to stow it. I'm going to stow that in alpha A. So instead of writing that down, I just stored it in alpha A. Now let's do B. Second, enter, second, enter. And that's going to be 1. And I'm going to stow that. Let me write it down. 0.00195, 0.00195, dot, dot, dot. Everybody with me? And that's going to be stow alpha B. So I stowed that in alpha B. Now let's do second, enter, second, enter, and I'm going to do 2. That's going to be 0.00998. And I'm going to stow that in alpha C. Stow alpha C.
You have a work email.
And then the last one, second, enter, second, enter, and 3. And that's going to give me 0.03225 dot, dot, dot. And I'm going to store that in alpha D. Stow alpha D. And now I'm going to add them all up. And if I add up those numbers, that'd be clear alpha A plus alpha B plus alpha C plus alpha D. 0.040443756034, And that's going to be 0.0444. If I'm rounding to 4 decimal places. But I'll show you another trick. Which way do we read? Left to right? Well, this is 0 plus 1 plus 2 plus 3. Couldn't I say that this is cumulative? I don't know how to spell cumulative. Up to 3? Could I say that? Since there's nothing below 0, if I say I'm going to 3, then I can say that's pretty much cumulative up to 3, right? Well, I can go to second vars and do binomial CDF. And what do you think the C stands for with CDF?
Cumulative.
Cumulative. So if I ever have a situation to where I need to add up everything up number, then I can do binomial CDF. So that would be enter number of trials, 20. Sorry, I had brain bubble there for a moment. P is 0.35. And X value would be 3. Look at there, it's the same answer. Golly! Or binomial CDF would be 20.35 and 3 will give you 0.0444. So you can do it individually, A plus B plus C plus D, or you can do cumulative up to 3, and that will give you the probability of X being less than 4. Okay, good class. Let me finish presenting and let me do the roll for those that came in late.